All right, I want to go ahead and go over the Rhodes Scholar dealing with the reading of topographic maps. And I have downloaded one of the older tests from North Carolina, the 2007 Regional Science Olympiad for Rhodes Scholar. And today I want to focus mostly on the topographic aspect, topographic map reading aspect, and how kind of they approach this test. Now the test consists of two parts. The first part deals with working with an actual state road map, and the second portion of the test will streamline it down to looking at a quad sheet, a topographic quad sheet. And so I'm going to give a quick overview of the test and then move on from there and go through the section that deals just with the topo. So this is the 2007 North Carolina Science Olympiad test, and you'll see that it gives you all the different things that you're allowed to have, a scale or a ruler. One of the things that I'm going to want our group to have is an engineer's scale. In an engineer's scale, let me go ahead and show you that. This is an engineer's scale right here. And you can see that these are broken down into inches, and each inch has an is segmented into 10 equal length segments. And so that's 1/10 of an inch, 2/10 of an inch, 3/10, and so forth. And it's much easier to do measurements on these maps using the engineer scale than it is the traditional inch broken into 16ths. And so each one of us will have one of these scales, each of you guys will have one of these scales that breaks it down into tenths instead. Okay, so back to the actual test. Now the test also allows you to use a protractor, which you've seen. You're given a story exam, we'll talk about that, but you're also given a response sheet to write your answers down. You're given a map, and most likely for the regional you're going to get a North Carolina map because you're familiar with that, and then you're given a quad map. Now you can bring a piece of plastic paper to overlay the maps if you want. We'll look at that later on, and it tells you some other issues in dealing with the number of points and everything. So the way I think we're going to break this down is, for those of us in the group, either one or two people will deal with the road map, and maybe one or two people will deal with the topo map. The topo map is more labor intensive. It gets very busy reading these topo lines and these and trying to find these locations, and so it's definitely one of the more challenging sections of the test. Okay, so what's the story? We have to derive hints that the story gives us. So we see here it's called a Nantahala photo shoot. And so these four individuals, let's just read it. Linda, Tom, Katie, Sid are geomatics students, and they live in Asheville, North Carolina. And so that should give us an indication kind of where in the geography of North Carolina this may be. You may not be familiar with Asheville, but it's in the western portion of North Carolina towards the mountains. And so they're there for the weekend. Sid has a serious photography hobby. He has heard that there's a view from this mountain called Standing Indian Mountain in the Nantahala National Forest, and that it's spectacular, and he wants to hike there. Tom says they can hike to the mountain from the Appalachian Trail. Along the way, he will take photos for a special album. So they unfold their North Carolina transportation map to plan the trip. Katie looks at the legend. It goes on, and so I'm not going to go ahead and hit this first section about the transportation map. I'll do that in a different segment. So anyways, the first segment goes all the way down through, only through the first 13 questions deal with the road map. The rest of it, probably 2/3 of the test, is devoted to this topo map. So we'll probably have two people on the topo map and one person on the road map to deal with these things, just to get through the time. You're only given 55 minutes, sometimes even less, depending on how much time is allotted at the end of the day. So you really have to get through this quickly and accurately to deal with finishing this exam. Okay, so it says when they get there, Linda unrolls the Rainbow Springs quad map, and they ask a number of questions. And I want you to kind of just look at these initial questions, and I'm going to go ahead and go to the actual topo map to begin this endeavor into the topo aspect. So the first question is, really the first three questions deal with just information you find directly on the map. And also, actually these two down here too also deal with the same thing. So let's go ahead and go to the map and answer these questions as quickly as possible. These are probably some of the easier questions. So here's our topo map, and the first question deals with when was the topography shown on the map done? So they want to know when was this topo map completed, the topography section. And so when you look at your map, you've got a lot of verbiage at the bottom. Most likely you're going to find your answers at the bottom of the map. Now let's go ahead and look at some of the aspects, because we're going to need to know some of these issues. So we've got the map, and we've got different colors of text. You've got purple down here and you've got black up here. And so let's go ahead and look at what the text says regarding the topo. So we read that it was edited by TVA, published by the Geologic Survey, blah, blah, blah. Okay, now here's our word right here. You see that? Topography by the photogrammetric methods using aerial photographs, 1953. Okay, they were taken in 53, it was checked in 57, but 1953 is, that's when the topography was done, all right? And so that answers that first question. When was the topography and the map done? And that's important to remember. Now it asks, when was the map revised? And again, if you look in this bottom left corner, you see in the purple, anything that's purple on the map is a revision to the map. And it says revision shown in purple, and the recompilation of woodland areas compiled by TVA from aerial photographs taken in 1976. Wasn't field checked until this information not field checked. So the map was edited in 1978. So the edits took place in 1978. They used 76 imagery, but it was edited and completed in 1978. So that's important to realize, is that anything in purple on this map is new, and it was an edited version, and it wasn't redone until 1978. So the topo lines were done back in the 50s, okay? But anything in purple, so we've got these little houses right here, we've got this road that's purple, and so these things were done later in time. And so there's a lot of information that's at the bottom of this map that will help us get to the answers to these questions. Okay, so the next question is they ask number one, when was the map revised? What is the contour interval? Now you can do that one of two ways. You can actually look at the contours themselves and try to find, you got the boulder contour lines right here, these bold ones. That one says 3,200 feet. And then you can go down to the next one, which the next bold line, and try to follow that around until you find, what it says. So there's 3,000. Let's see if that's correct. 3,000, yeah. And that's 3,200. So we see that there's 200 feet in between these 5 lines. So if you divide that, you find out, 200 divided by 5, we find out each of those topo lines between these things, each of these lines is 40 feet of elevation change. And you can do it that way, but it's really easy. If you look down here, it tells you directly that the contour interval is 40 feet on the map. So you can do it right there. So that makes sense. Okay, the next question is, as you're reading the storyline, it says, Tom says the scale is listed several ways on the map. What is the scale ratio on the quad map? Now, if you remember, a scale ratio is just 1 to something else. 1, it can be a ratio where it's like, 1 over something, or it can be looked at 1 to, in this colon here, to 24,000. So that's our scale ratio, 1 to 24,000. If you remember what this means, this is a scale ratio. It's not the scale of the map as far as what you're understanding, like 1 inch is equal to something. What it means is that 1 of something on the map is equal to 24 thousandths of the same thing on the ground. So if we say 1 inch, we can make that inches. 1 inch on the ground, on the map, is equal to 24,000 inches on the ground. And you say, well, what is 24,000 inches? If you divide 24,000 inches by 12, it'll give you feet, because there are 12 inches per foot. Divide 24,000, we know that the scale is 1 inch is equal to 2,000 feet. And so we can look at that too by taking our inch measurement, and here's feet right here. Here's the scale. You can look at the scale bar too. Take it where it says 0, and you see at the 1 inch mark we've got 2,000. So that's 2,000 feet. So there's two ways to express this scale. One is in ratio, scale ratio, which is the 1 to 24,000. That's what they wanted. And then the second thing they ask is what distance does 1 inch on the map represent? Well, we can do it by dividing that scale ratio by 12, okay? Or we can just take our ruler and do what I just did. 1 inch is equal to 2,000 feet. So that's the answer to that one. Okay, so those are all the things that we needed to deal with in looking at just the map itself. Now, we're going to get into some questions here that require kind of locating, navigating, either using a coordinate system such as the UTM, which we discussed earlier in an earlier YouTube video, or the state plane system, because those are both existent on this map. But also, you're going to find later that there are going to be questions dealing with looking at where latitude and longitude is on this map. Now, that's a little bit more challenging. I've got to get got to find one answer key as we go. I had everything laid out perfectly. Okay, here we go. All right. So before we start, I want you remember that we learned about UTM, the UTM coordinates and the state plane coordinates on these maps, and also the latitude and longitude. And so the longitude runs west to east or east to west as far as looking at it at the base of these maps, and there are lines that extend from pole to pole. And so if you take this map right here, here are the longitude lines. So this is what's called a 7.5 minute quadrangle map. And the ways that you look at this thing and read this point right here at the corner is 83 degrees, 37 minutes, and 30 seconds. And so when you take and you go completely to the other side, so this is the western portion of this topo map, take it all the way to the end, it should be 7.5 minutes difference all the way to the other side. So when we get there, we see that this side is 83:30. So we've got 83:30 as being our easterly side, and the other side was 83:37:30. So that's 83 degrees, 30 minutes, and 0 seconds. And so if you subtract 83, let's do it this way. You subtract 83 degrees, 37 minutes, 30 seconds, minus 83, what is that one? 30 minutes. Okay, we bring down the 30, and that's 7. So that's 7 minutes, 30 seconds, or 7.5 minutes. So there's 7.5 minutes of longitude across this bottom region. And so we have to get to a point of figuring out, well, let's relate that to feet, because you're going to have to find out how to locate, where you are on this map. And so it's a little bit challenging, but you have to find, where these demarcations of longitude are. And so what I did earlier was, if you look at the way the map is run, you've got from the far right corner. Can I see the far right corner? Got Gosh, you know what I have to do is make this larger so everybody can see it. Yes, there we go. Okay, I can do it this way. So from this corner where this pointer is, hopefully you can see the pointer, 8330, and if you follow this along, you can find that we have another little tick mark there at 3230. So that's 2.5 minutes from there to there. So 2.5 minutes equals a certain number of feet. How many feet does it measure between those two elements? So what I can do is just go ahead and take my scale and measure between this tick mark right here is where my 0 is, and we know that that's 2.5 minutes, all the way to the corner, which is, it looks like it's 6 point, I would say right there at 6 point, maybe not a half, 6.2, not 5, maybe 6.24, 6.23 inches. So we know that the distance on the longitude side is, for 2.5 minutes, I'll just do it that way, is to 6.243 inches. When you look at feet, we know that 1 inch is equal to 2,000 feet, so I'm just going to multiply that by 2,000. So I know that 2.5 minutes, it's actually minutes, that's seconds there, 2.5 minutes is to this figure. I think I calculated this earlier, but let's just go ahead and look at the math. we'll call it 2.235. 235, just for more technical, times 2,000 equals, so we know that the distance in feet is 1 to 2470 feet, 12,470 feet. So 2.5 minutes equals that. Okay, we need to get that down into a figure that we can use. And so I'm not going to go through all the math for you right now, but actually I did it right here. Let's go ahead and look at this. So 2.5 minutes, just so you guys know, is equal to 150 seconds. Now, how did I get 150 seconds? 2.5 minutes is equal to, a minute's equal to 60 seconds, right? So if we multiply that by 60, a half a minute is equal to 30 seconds. So it's 60 times that, so it'd be 60, 60, and then 30. So that would equal to 150 seconds. And that makes sense. When you're looking at time, if I told you you've got 2.5 minutes to run around this track a couple times, I'd say, how many seconds is that? And so you just go ahead, you know there's 60 seconds per minute, and then when you get that, you get 150 seconds. Because I want to get it down to the seconds realm, because that's how I'm going to navigate. Okay, so let's look at just the longitude right here. So the longitude, it's kind of busy right here. If you look at this guy right here, 6.22 minutes is the same thing as 150 seconds. What does 1 second equal to, or 1 inch equal to? So 6.22 inches, I'm sorry. 6.22 inches is equal to 150 seconds. What does 1 inch equal to? Well, 1 inch is equal to, when you go ahead and do the math, you cross multiply. I don't know how much in algebra you're done, but you do 6.22, x is equal to 150. You've got to solve for x, so you divide both sides by 6.22. And when you do that, you get the fact that 1 inch on the longitude is equal to 24.1 seconds. Now we're getting into a place where we can actually do some measurements with longitude. So 1 inch is equal to 24.1 seconds. We can measure that. But I want to get it even further distributed down to tenths of an inch, because I may have to do that. 1/10 of 24.1 is actually, you just take that and divide by 10. So every tenth of an inch, so if you look at my ruler here, every tenth of an inch, one of those guys, from the 0 to there, is equal to 2.41 seconds. Now, are you going to have to do this math during the exam? If it's a North Carolina map, if we're working in North Carolina, it's a quad map in North Carolina, and in this location, these figures will hold up across the board. Okay, so whether you're working in eastern North Carolina or western North Carolina, your measurement for 1/10 of an inch is equal to 2.41 seconds, regardless, throughout North Carolina. So I'm going to have this this figure down on your sheet, so you know this originally coming in. So you're not going to have to calculate this like I just did. I just wanted to show you how we got at it. Now, in the regional, once you get past this stage, you may have to calculate this for a different area of the world, in a different area of the United States. Okay, so now, does this carry over for lines of latitude which run north-south? And the lines look like they're east-west lines, but they give us the measurement of north to south. Okay, so lines of latitude, they start at the equator at 0, and they go all the way up to the North Pole, which is 90. So 0 degrees all the way to 90 degrees at the top of the North Pole, reading up. And so you can see right here it reads upwards 35 degrees, and it'll go up 7 minutes all the way up to the top. So if I was to flip this over to the top of the map, we remember the bottom was 35, the top is 35, 730. So we're increasing as we go up. So we know that, and there's your 7.5 minutes. That's the difference between those two. And so we do the same thing. We look for the tick mark, 35 degrees right here, and then 2.5 minutes up, we see it's right there. You guys see that? And so if I was to measure, now remember the last one was like 6.22. When we measure 2.5 minutes of latitude, we see it's bigger. It's 7, what is it? Do you see it? There's the bottom. I can't see the bottom here. I don't know if there's a way to reduce the size. Huh. Anyways, I'll just tell you what it is because you can't see it completely on here. I'll do it this way. There we go. So there's one edge. Can I see the edge? No. Let's see, it's longer. Okay, there's 2.5 minutes up here, and then I'm going to measure all the way to this end, and you're just going to have to trust me and when I tell you the actual measurement. So the actual measurement is about 7.53, something like that. So we remember the other one was like 6.22 something. This one is 7.53. So the scale is going to be different. And so when we do the math, we find out, let's bring the math back. Okay, so if you look at this guy right here, 7.55 is to 150 seconds right there. So you're going to have to see my ugly fingernail. 7.55 is 150 seconds, as 1 inch is equal to x. And I just do my cross multiplication, okay? And I get down here that 1 inch is equal to 19.9 seconds of latitude, or 1/10 of an inch is equal to 1.99 seconds, approximately 2 seconds every 1/10 of an inch. Okay, so now we've got it. So now, when we measure stuff, we know that longitude is down here. 1 inch is equal to 24.1 seconds, or 1/10 of 2.41 seconds. And latitude is just above it 1 inch is equal to 19.9 seconds or 1.99 seconds. This will come in handy as we answer some of these questions. That was long, involved, but I had to get you to see how you navigate in latitude and longitude, which is much more difficult because they don't have feet put to them like the other coordinate systems do. If you give me state plane coordinates, I can navigate real easily, and I like those better than working in the latitude and longitude work, because you're taking these obscure degrees, minutes, and seconds, and you've got to translate them into feet, and that's all I've done. Okay, so now that we're all thoroughly exhausted from hearing that explanation, we will move on. And so, here's what we've got. I wonder if this does this. Oh, there we go. That gives me more ways to look at it. Okay, so we've already answered all these questions, and it gives us another question that's interesting here. It says, why are the okay, it says, Linda says, we just passed through Winding Stair Gap. There are very steep rock faces on both sides of the road where the road was cut through. I don't see contour lines that look like that near the road. So you guys understand that when a road is put in, the contour lines will be affected by that because they had to take away earth, and so it's going to show it's where it cuts into a mountain. There's going to be a section that on a side of a mountain when a road goes in, you've got contour lines which are really, really tight together. Remember, that makes it real steep. And then when it comes to the road portion, which is pretty wide, it'll flatten out where there's, it's very wide in between. And then it'll do the same thing going down the opposite sides. And so you don't realize this, but what you have to remember back on the road mapping portion is that they said they came in on this road right here, which is the new Route 64. Now remember, this comes in as purple, and the indication is they mentioned this gap, this Winding Stair Gap. Now luckily, we know, excuse me, Asheville is up in this area, and you'll know that as you come on in and looking at the roads map. So you know that they're coming this direction in their car. And you can see that there's the purple road, and she's saying that, hey, I'm looking at this Winding Stair Gap and this road coming through, and it doesn't look like the contour lines are cut through. It should be different, like I was just explaining. But it's not. What would your answer be to that question? Well, the answer to that question would be the fact that the contour lines were done in like 1950-something, and the road was updated. This road was actually put in like 1978 or 76, whatever we had mentioned. And you have to put the right dates down. So go look at the dates at the bottom of the map, and when the map was initially, the contour lines were initially made, and when the road was initially put in and updated. And you make those statements. You have to put those dates in and say, of course the contour lines are not going to be shown different because the road wasn't there at the time when the contour lines were put in. So that just answers that question fairly simply. But you have to kind of do a little bit of teasing out of the information. Okay, so that answers number 22. So it says the students start to plan their hike to Standing Indian Mountain. Okay, so now we've got to find out where is Standing Indian Mountain. It's kind of difficult in a lot of ways. We have some indication that it's close to the Appalachian Trail, and earlier we found out by looking at the road map that it's split between two counties, I think Clay County and Macon County. So there are some indicators. The thing about this test that hopefully it's going to be different for you guys, this is an earlier test from 2007. This is challenging looking at this map because it's very busy with names. And I found myself having to take what hints they gave me, like it's on this boundary, but they don't give you a real good clue or indication where some things are. And so I found myself really having to peer in and find these things, which is incredibly difficult at times. And so take whatever information you can get and try to navigate to find the points of interest that they're talking about. So they want to plan their hike to Standing Mountain. Well, the first thing I want to find out, well, it says, why are the elevations shown for the top of Standing Mountain different on the quad sheet than the transportation map. And so we have to find Standing Mountain. That's the first thing. So let's take this road, we take it on down, and we see, oh, there's the, this is the dividing line between counties. It has that certain legend right there, this little dotted line, dotted dash line. And you can see Macon County on one side and Clay County on the other. So we follow that down, 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 crosses the road. I'm still not finding my mountain. Continue to follow it down. There's Macon County near the Appalachian Trail. It continues on down, even where this is right here. And then finally, when you look at it, we find there it is. So it's really, you know, sometimes you can take the transportation map and get a good feel on where it is. You might see this loop in the road, but you find out, okay, it's kind of in this direction. Talking about this loop over here. And so you use whatever you can to kind of get yourself referenced, and then you find your actual elevation. Now you'll find that they have Standing Indian Mountain, and they've got an elevation of 54.99. So they've got an actual elevation there. You'll find on the road map that they have an elevation of like 5,500. And they ask you the question, why are there differences between the two elevations? Well, the answer is that this one rounded to the nearest foot on the topo map, whereas on the transportation map it rounded to the nearest 5 foot, because you can see other maps, other mountains in the area that are in 5 foot increments. And so that's the reason why this is different. They don't go to the actual foot on the transportation map, but on the topo map they're able to do that. Okay, so now we start reading what's happening. The students decide, it says the students decide to split into 2 groups. Sid and Katie will drop Linda and Tom off at Riley Cove on the main highway, and then turn and drive on the medium-duty and light-duty roads to the beginning of a foot trail. When they arrive, Katie takes a reading with her handheld GPS receiver. She reads 35 degrees, 1 minute, 37 seconds north, and then 83, 30, 22 longitude. So now you can see that we've got to use our new scaling of latitude and longitude to navigate to where her reading is. And so that's why I had you go through that painful process of knowing what the scale is for latitude and longitude on these quad maps. Okay, so we need to take information here. Sid and Katie drop Linda and Tom off at Riley Cove. Now, so we go back to our original place here. We know they're driving on this road, and this is the tough thing, because you've got to navigate down the map and to find out, you know, where is Riley Cove? You know, where are these different things? And actually, I can't find it right now. Oh, there it is. There's Riley Knob. So there it is. So we get to this. We see Riley. Okay. And then we take this map, and there's Riley Cove. So they drop them off at Riley Cove. Now, they dropped them off at Riley Cove. We understand they're probably going to be taking this trail. There's a trail right here, this dashed trail at Riley Cove, which follows the cove itself. It goes on down. If we flip it over, we can see it continues on there. So one of the groups is taking this trail. And if we follow this trail all the way out, it kind of comes, it loops around, does this meandering, blah, blah, blah. Ultimately, it's going to get close. It does a lot of stuff, but it goes down here, and then you can barely see it, but it connects right here, follows this area right here, goes along here, comes down, goes up, blah, blah, blah. It really attaches to the Appalachian Trail. So is the trail, and then ultimately it gets down here to Standing Indian Mountain. So that's a long route. I don't know how they're going to make that. I think they got the short end of the deal by having to take such a long way. So that's one group. They're going to start up here. They're going to start here at Riley Cove and maneuver. So they're there. But the other group we need to find, where are they? So she reads this latitude and longitude, and they ask a question: what ridge is approximately 0.35 kilometers northwest of where Sid and Katie's location is? And so, well, let's find out where Sid and Katie are located. So remember, first thing we want to do is we want to take, let's get down here. So we know that there's 35 degrees. We know, okay, according to this, they went up 1 minute 37 seconds. Okay, if we go up, we know it's somewhere in between here, this 230 and 35, so it's kind of in the middle somewhere, a little bit towards the top, so it's probably the top 2/3 somewhere. And longitude, it says that it's at 83, 30, 22, so it starts here at 83. Now remember, when the way that longitude reads is from east to west, so it gets larger going east to west. So we know going this direction towards the west is getting bigger. So the number is 83, 30, 22. So it's pretty close to right here, because that's 2.5 minutes there to there. So it's going to be somewhere in here. So we know it's kind of in right in here. And so when you do the math, we found out. Remember, go back to my math. Let's go ahead and get the location on the longitude. So the longitude, hold on, it's 1 minute 37 seconds. I don't really want to deal with the 1 minute. Let's see, I think we said for longitude, 1 inch is equal to 19.9 seconds. So how many, let's go ahead and look at all these seconds. How many seconds is it? Let's don't do the 1 minute and all that. How many seconds is it difference between 35 and the 35-137? So we know if you subtract 35-137 from 35, that's 1 minute 37 seconds, or the 1 minute is 60, that's 97 seconds. Okay? So we know that it's 97 seconds going from the 35 mark. So if I take this and I say 97 seconds, my latitude, if you remember, if you divide, how many inches is it going to be? Divide the, 1 inch is equal to 19.9 seconds. So if I divide that by 19.9, I'll get the number of inches that I've got to go. So 97 divided by 19.9 is equal to 4.87. So I want to go north 4.87 inches. Okay? So that's equal to 4.87. If I take my ruler and look at where 4.87 is, it's going to be like 4.87, like right about here, here-ish. Okay? So it's going to be here. The little dit there, I don't want to get too much into it. So just remember that was 4.87. And then on the latitude side, we see the difference is what? 83, 30, 22. So we're going from 30, we've got 22 seconds. So it's 22 seconds difference. We learn that latitude, if we go back to my seconds, latitude, 1 inch is equal to 24, so it's just a little bit under an inch. So if I take my 22, okay, there's my 22 seconds, and divide it by 1 inch. If I divide that by 24.1 seconds, because that's going to be equal to an inch, we know it's a little bit less. So 22 divided by 24.1 gives me 0.91 inches. So I know that the distance over to this side is 0.91 inches. So I get my tenths ruler, I go to about where 0.91 is, I make a little mark right there, and then I just maneuver. There's my dit right there. So you see that guy right there? And this is the dit here. I try to keep it as parallel as I can to each side. I look at it. So she takes a reading. It's kind of right there. So I think she's closer to this little trail right there. So that's about where they are, right there at that juncture. And so the question, so if we know that they're right there, the question is, what ridge is approximately 0.35 kilometers to the northwest of Sid and Katie's location? Okay, so we'll come back to this little area that we know they're located. So now they're working in the kilometer world. They're really trying to confuse you, but don't be worried because they've got a kilometer scale at the bottom. We see that 1 inch, actually, these are the different, this is 1 kilometer, so 0.5, 1 kilometer. So we want to go 0.35, 0.1, 0.2, 0.3, measuring from that 0 mark, 0.1, 0.2, 0.3, go a half. So I take my 0 in, that's where the half is. Can you see that? Yeah. All the way down to 0, and I see that I need to measure 0.6 of an inch. That's about 0.35 kilometers, 0.6 of an inch. And they say to go northwest, and I really don't need my protractor, but we'll do it anyways. So remember 0.6 is the distance that they're looking at. So we found out that this really is our area right about here, right? And so we want to go northwest. Northwest is like up in this direction right here if I even it out. So I'm going in this direction. We want to go like 0.6 on that. So that's my northwest direction right there, going from my initial point where she had measured that GPS location to right about there. And then she says, well, what ridge are we on? Okay, so you see that. You're right on Indian Ridge. That's what you're looking at. Now, so I know that they took a trail to navigate all the way to Indian Springs. So without even looking, I can say, oh, yeah, they took this trail. So they navigated this thing, meandered, da-da-da. They got the shorter trail. They linked up with the Appalachian Trail here at Beach Gap. And then they would walk this thing up along this Tennessee Valley Divide all the way to your mountain, which is Standing Indian Mountain. And so Beach Gap is where they kind of have the confluence of where they went. All right, so we're all really tired now because I've been talking a long time, and I should have brought a glass of water, but I didn't. See what the next question is. So Katie and Sid make the long hike on the trail they found. They join the App Trail at Beach Gap, which I just mentioned, on the county boundary. They turn northwest and hike up the Blue Ridge. So they hike this trail. Let me zoom it in a little bit. There we go. So they hike this trail. There's your Appalachian Trail, because it mentions it right there. And they get to Beach Gap, which they just mentioned, right? And they hike, it says, at the county boundary, they turn northwest and hike up the Blue Ridge. Okay, there's the Blue Ridge. So they hike northwest, which is this direction. Okay, and so that's what they're doing. They're hiking up northwest. The question that they ask is, what significant geographic line are they hiking along? Well, we just saw that. This is Tennessee Valley Divide. And a divide just mentions where water goes in one direction versus the other. Okay, and they actually mention what they, as they finally, that's the significant geographic line they're hiking along. They finally arrive at the top of Standing Indian Mountain. Sid takes a photo. Katie says, the Cherokee legend is that the Great Spirit turned an actual Cherokee guard into the mountain. The guard says, the guard sure has a spectacular view. Sid says, we're very fortunate to be in an important place. All the rainwater that falls in the valley to the southwest of us eventually runs to the Atlantic Ocean. Okay, so that's this direction here. Going this way is southwest. Everything else that runs to the north eventually runs into the Mississippi, and we can see that from here. Now, questions 24 and 25, what direction does the Tallulah River generally run on the quad maps? They asked this kind of random question, you know, what direction does the Tallulah River run on the quad map? And I've got to find this river. Now, it's got to be close to where they are. And so if I look over here, remember rivers are blue, and we've got the river right here. There's the Tallulah, whatever it is. Tallulah, that's I guess how they pronounce it. And it's either running north-south or south to north. We've got to find out where the elevation is higher. So if we find the elevation, we find that as you go this direction, you're going up in elevation. You're going up these mountains right here. So this river is flowing downwards to the south, which makes sense. It's flowing away from everything. So it's a southerly direction. You're going to have to answer questions like that. What direction does this river run? And then it asks, what direction does Big Indian Creek generally run? 3 points, okay? So I need to find Big Indian Creek, and I don't know if I can find it right away because these are some of these were very difficult to find. So you're going to have to look at all these creeks. There are these light marks, and then try to find here's Big Indian Creek. I just found it, luckily. So it's somewhere around the area of this mountain. So there's Big Indian Creek, and they're wanting to know what general direction does this run. And so it looks like that, as you look up, this is a ridge, so it's coming down, 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 coming down, coming down, so it's running up north. You can see that. So there's a ridge. Anytime you're up on a ridge, you're going to go down. If you want to check yourself, check your elevation differences between the brown lines and know that you're running in a certain direction. So you're running north. Okay, so so you're going to have to answer questions on direction of flow, of stream flow, river flow, whatever that is. They also, so she asked, well, what latitude and longitude, Katie takes another reading with her GPS receiver. Now she's standing where Lookout Tower is shown on the map. What latitude and longitude will she read? Give your answers to the nearest second. Okay, so this is another, using what we just mentioned earlier, how do we get to the actual location using latitude and longitude? What latitude and longitude are we reading here? So I would take this this area right here, and I would align it so that I'm parallel to the line below. And so what you may want to do, the easiest thing to do, I think this is the best way to do this, is to take a straight edge like a piece of paper. So we've got this piece of paper. Let me get a better one that's just by itself. So if you want to get the actual location, because we want to get as accurate, they do look at accuracy, not just a general location. So if I keep this side right here, okay, lined up with this line, it's going to be exactly measuring, out to where, here's your Standing Indian River, here's the top. You see it? Standing Indian River. And if I take that across, I make a little dit, and there it is right there. Okay, so that's my location on the latitude side. And we do the same thing on the longitude side. So there's Standing Indian River, and I'll keep it flush with the bottom portion. Okay? And so I take that, and I find out when I keep it flush, I see that there's my mark there. So I've got my marks. And then all I do is I measure, well, how many inches is it from one area to the other? So if we do this in tenths, I measure that this is 5 point, you can't see it. Okay. Like let's just say 5.8. So 5 inches, 8 tenths, 5.8 inches across. And in doing that, I go back to the numbers that we already calculated. Okay. We know that on longitude, on the bottom portion, longitude, so we measured 5.8 inches, and we know that 1 inch is equal to 24.1 seconds. So if I multiply that by 24.1 seconds, .8 times 24.1 gives me like 139.8 seconds.